Hi there. Question 13. Alkynes are a family of hydrocarbons which contain a carbon-to-carbon triple bond. 3 members of this family are shown. Suggest the general formula for the alkyne family. So the general formula is the one that goes sort of CN and then H and some sort of formula. So the best way to do it is to write down how many carbons and how many hydrogens. C3H4, C4H, 1, 2, 3, 4, 6, C5H8. And there's a general sort of formula appearing here. So this is like C5H10 take away 2. So it's like CnH2n minus 2. And that's what I shall write down here. CnH2n minus 2. Now if we have a look at the Marcus guidelines, you can see that that's the top one, but they're also letting you away with writing it in a few other ways that aren't so good, but the top one is best. Alkyne can undergo polymerization to form polyethine. Draw the repeating unit in the polymer polyethine. Now the repeating unit is the bit that repeats, and the monomer is the molecule this molecule. So that little ethine molecule is the monomer, and you get lots of them joining together to make the polymer. The repeating unit is not the monomer, the repeating unit is just the bit that repeats. So if I draw that exactly, and then we can have a look at the Marcus guidelines. So these little join-on bonds are included, and it says allow one end bond to be missing, but you're better off just having them both in. Part 2. Name the type of polymerization taking place when ethine is converted to polyethene. And the answer is addition. There are 2 types of polymerization. There's addition and there's condensation. Addition is when lots of little monomers get added together, and condensation is when you have 2 different types of monomer, and every time they link together, a water molecule or some smaller molecule gets condensed out. So every time there's a link, another molecule gets thrown away, the smaller one. That's condensation. This was just straightforward addition. Addition. Alkynes can be prepared by reacting dibromoalkane with potassium hydroxide solution, 1,2-dibromopropane and propine. Oh no, sorry. This equation here takes place. Draw the full structural formula for the alkyne formed when 2,3-dibromobutane reacts with potassium hydroxide. So what we can see is that in this reaction here, these 2 are gotten rid of and a triple bond ends up being there. So we want to get rid of those 2 and put a triple bond. Oh, no, there's no. You've got to have 4 bonds around each carbon. So that should be it. That's how you do it. I'll show you in the Marcus guidelines. There we go. The structure of 2,4-dibromopentane is shown below. Suggest a reason why 2,4-dibromopentane does not form an alkyne when it is added to potassium hydroxide solution. And the answer is because the bromine molecules are not next to each other, which I'll just show you in the Marcus guidelines. The 2 bromine atoms are not next to one another. Go. Thanks for watching. Bye.